Tonight's video is on balancing chemical equations. This is part of Cool Chemistry Show Activity 4. This is the first video in the series where I'm going to introduce balancing chemical equations. There will be a later video on balancing different types of equations. Here are my objectives for you tonight. One is that I can identify reactants and products for a chemical reaction. The second part is that I can balance a chemical equation. So we're going to start out with something that you're familiar with here, and that is cooking. All right, everybody cooks here, and when you look at a cookbook, what you have here down below is your ingredients. And then at the top we have what we're making. Okay. Now, if you were to use chemistry terms here, what we would be talking about would be the ingredients would be our reactants. This is the starting material. And what we're making would be our products. Because cooking is actually a chemical reaction. It's just a lot more complex. When you put together breadcrumbs and Romano cheese and salt and an egg and boneless pork loin chops and everything else, what you end up with is pork chops with tomato and arugula. And it tells you how many it serves in that. So everything that you put in as ingredients or reactants ends up in the products, and you know how much you're going to make. We can apply this same concept here to chemistry. And so on this slide, for chemical reactions, I've provided a general equation for the formation of what's called magnesium oxide. And that's formed from the reactants of magnesium and oxygen. So always on the left-hand side of the arrow is going to be my reactants. And then on the right-hand side is going to be my products. And if you remember what I said on the previous slide, everything that's on the reactant side has to end up in the product side. And if we look at this, what it says right now is we have one magnesium atom plus two oxygen atoms going to form magnesium oxide. And this magnesium oxide is only one magnesium and one oxygen. So the question becomes, where did the other oxygen go? If it's in the start of our reaction, it has to be in the ending part too. And so what we're going to have to do with this is we're going to have to do what's referred to as balancing chemical equations. And this process is going to allow us to balance this so that everything that's on the reactant side ends up in the product side with nothing extra. And then we will update the initial equation to take that into account. So let's continue with our example of magnesium and oxygen. What I have here is I have magnesium plus O2 forms MgO. And the way I'm going to go about balancing this here is I'm going to start by step one. I'm going to make a T-chart separating my reactants from my products. And so I'm just going to draw a T just like that down below. And the reason I do this is so that I can easily identify what are my reactants, what are my products when we get everything put together. Step two of this is I'm going to copy down all of my reactants that I already know I have. Because if it's listed in the equation, it's going to show up in my product somewhere. And so I'm going to start by copying down one magnesium. Oops. And then O2 stands for two oxygens, so I'm going to put two oxygens. Now, I'm going to copy this onto the product side, and I want to organize it based on how I'm going to use it. Okay? I'm going to use it as MgO. And so when I place it over here, I'm going to put my one magnesium atom with one of those oxygens to indicate that that is a complete set. So if you circle this, there's one MgO. But then I've got the second oxygen that I'm going to put down below. Now, if you look at this, our original problem does not say plus MgO plus O. Alright, it only says MgO. So what I have to do is I have to either add more magnesium, Mg, or more oxygen on the reactant side until all I have on the product side is MgO. And the way I can add this is anything that's separated by a plus I can add individually. So I can add an Mg because it's separated by a plus from the O2 there. But the O2 is written as O2. So if I need to add more oxygen, I have to add 2 more oxygens. So looking at this, I see that I have this oxygen just by itself. So I'm going to add another Mg. And if that's on my reactant side, that has to be on my product side. And we will have then formed a second magnesium oxide. So when you look at this, the last part that we have to do is we have to make sure everything's balanced, and we need to update our initial equation to indicate the amounts of each item that we need to make our products and how much product we made. So I have nothing but MgO on my product side. I have 2 magnesiums on the reactant side, 2 magnesiums on the product side. I have a pair of oxygens on the reactant side. I have 2 oxygens on the product side. So everything I add on the reactant side is on the product side. Updating my equation. So I said I had 2 magnesiums. So I'm going to put a 2 in front of Mg to indicate that it took 2 magnesiums. And I have these 2 oxygens here, but again, you can see that this is written as O2 already, so we're just going to leave that as it is. If you want, you can put a 1 out front to indicate that there was 1 of them, 1 pair. And then the last part here is I have MgO, and I have 2 of those, so I'm going to put a 2 out front to indicate that there were 2 magnesium oxides. This is the process of balancing chemical equations. The second part of this is going to look at different types of equations, but you do the same process anytime you do it. If you have any questions, feel free to email me, ask me in class, contact me through EDU 2.0, you can contact me through Twitter, and I will see you tomorrow in class.